Hello students, I am Rohitash and I am here for discussing the topic of junction and oxide isolation of IC technology. Now, some following terms in IC technology: diffusion. Diffusion is the term that means that the movement of the molecules from high concentration region to the low concentration region. We have already discussed this in our class. Photoresist is a material that reacts with light and forms a chemical compound. Now, etching is a selective removal of the material from the substrate. So, the next slide shows junction and oxide isolation. So, as an introduction, the device isolation is the ability of technology to allow each device to operate independently of others devices. To fabricate IC, some sort of isolation module is necessary. The parameters of such module are density, process complexity, yield, planarity, and parasitic effect. So the figure shows junction and oxide isolation. Simple junction isolation in bipolar transistor. The emitter of two adjacent transistors are automatically isolated from each other because each emitter is totally enclosed in base diffusion. For the layers to be isolated from each other, there must be large energy barriers between the holes in the two base regions. Now, next slide shows calculation of isolation length. How isolation length can be calculated. To get an estimate for the isolation length required for a technology, consider the densest portion of the circuit. Then move to the figure. Read of the maximum permissible isolation distance. For example, if the densest portion of the circuit has 10 raised to power 15 transistors per centimeter square and 50% of the area is active in that region, the device separation must be 10 micrometer or less. Now, cross section of parasitic MOSFET. So, formation of parasitic MOSFET, if we add an insulating layer and a metal line over the substrate but do not contact both transistors, a parasitic MOSFET exists. The collector of two transistors act as source and drain of the MOSFET and the metal line act as the gate. If we apply large positive voltage to the metal line, the surface of the area underlying may invert, turning on the parasitic MOSFET. The threshold of parasitic MOSFET should be at least twice of supply voltage, which ensures that they will not turn on even in the presence of excess supply voltage or voltage spikes on the supply line, nor will leakage current be excessive. The plot of threshold voltage as a function of substrate concentration is shown in this figure. To achieve a suitable large parasitic threshold, we should select a thick field oxide or large substrate concentration. Now, we are having guard ring isolation. The device separation can be reduced and the parasitic threshold increased by addition a P plus diffusion barrier ring around each device. This is called guard ring isolation and that can be shown in this figure. Guard ring requires an additional mask that must be aligned to the transistor. The guard ring must be deep, at least 2 micrometer, and the depletion layer should be below the guard ring, shortening out the devices. So this is our topic. Thank you.